properties of division of polynomials. So basically, you're just doing long division. Make sure the inside of your polynomial is in decreasing order and it's not missing a power. The outside one is missing a power. You need to have that in there. So make sure that it goes in decreasing order and not missing. Okay, you did this in Algebra 2 last year, second semester. You compare the first term with the first term, and you need a 3 and an x to the second. And then what you do is you multiply everything on the outside by 3x to the second. And you get 3x to the fourth plus 0x to the third plus 3x to the second. Draw your line, and after you draw your line, make sure you switch your signs. If you switch your signs, these two cancel out. 2x to the third, take away 0x to the third is still 2x to the third, minus 4x to the second, bring down your negative x. And then you do it again. The first term and the first term, you're missing a positive 2x. You're going to have 2x to the third. You're going to take all of this again and multiply it by these three again. So you're going to get 0x to the second plus 2x. Draw your line and switch your signs. You need that in there because if you didn't have that in there, this one, 2x, would have been under the x squared, and that wouldn't have been the same similar term. So that's why you need that 0x in there. This goes away. This makes a negative 4x squared. This makes a negative 3x. And you keep going until this first term is equal in power to that one or less than it. So you're going to put, it's missing a negative 4. Negative 4 times x squared is a negative 4x squared. A negative 4 times 0x is a negative 0x. Negative 4 times 1 is a negative 4. Draw your line, switch signs. This disappears. This makes a negative 3x minus 6. This is smaller than this. So you're finally done. So that is the remainder of a negative 3x minus 6. Okay, let's do another one. A negative 5x to the second plus 3 and x cubed plus or minus 3x plus 9. The negative 5x to the second plus 0x plus 3 goes on the outside. It's missing the x. This one's going to be x to the third plus 0x to the second minus 3x plus 9. Always make sure it's decreasing order. You're not missing a term. Okay, this is the last one was more of an Algebra 2 problem. This is more of a college algebra problem. You know it needs another x, but what up here times a negative 5 would give you a 1 in the middle? Wouldn't it have to be a negative 1/5? So a negative 1/5 times a negative 5 makes a positive x to the third. And this is going to be a 0x to the second. And this is going to end up being a negative 3/5 of an x. These two cancel out. These two cancel out. I need to change a negative 3 to a negative 15/5 is the same thing as a negative third, which gives you, you got to try your, switch your signs, remember. This makes a negative 15/5 plus 3/5 makes a negative 12/5 x plus 9. This power is smaller than that one, so this is your answer with the remainder of a negative 12/5 x plus 9. So that's called long division. before I think we have one more long division. Yes, we have one more long division one. They're still asking you to do long division, which is called the remainder theorem. They want you to see if c, x minus c, is a root or not. So you're just going to put an x minus 3 on the outside, and then you're still going to put 2x to the third plus 4x to the second minus 3x minus 1 on the inside. So all I did was replace the c with the 3, and that's what's on the outside. The difference between this and this is 2x to the second. 2x to the second times x is 2x to the third minus 6x to the second. Draw your line. Don't forget to switch your signs. The first two cancel out, but you're going to be left with 10x to the second minus 3x. Compare this x with 10x squared, and it needs to be a positive 10x. 10x times x is 10x squared, minus 3 is a negative 30x. Draw your line and switch your sign. The 10x squared and the negative 10x squared cancel out. This is going to end up being 27x minus 1. X and 27x is a positive 27. 27 times x is 27x. 27 times a negative 3 is a negative 81. Draw your line. Don't forget to switch your signs. And you get a remainder of 80. 3 is not one of the answers to the problem because you did not get 0 for a remainder, which we'll talk about later on too as we get into this chapter. Before we move on to the factor theorem, I want to talk about one other thing on this page. You're going to be tested on the intermediate value theorem. And I just want to bring up what the IVT is, the intermediate value theorem. It says that some f of x function, x to the fourth minus 4x to the third plus 3x to the second. There are 4 answers to this problem, and they're asking you let x equal a negative 1 and let x equal 2. So what you're going to do is you're going to put a negative 1 in, and then you're going to put a 2 into the equation. And to hurry this up, when you plug a negative 1 up there, you're going to get an 8. And a 2, you get a negative 2. And if you graph this, a negative 1, 8 is here, and a 2, 2 here. What this means is the intermediate value theorem says that there are 4 solutions to this problem. The solutions are when it crosses over the x-axis. There's got to be one of them in between there because you crossed over between a negative 1 and 8 and 2 and a negative 2. So you're hoping that your y values are opposite signs if there's a solution in between. You're going to be asked to do that on the test, and you're going to be asked to do this in the book. It's called the intermediate value theorem. All it says is that there are 4 solutions, and the solutions are when a graph, for example, a parabola, there's a solution here, and there's a solution here. And the reason why there's a solution is that there's a point over here, and there's a point down here, that the y values have to be opposite in order to cross over. So you just have to confirm that. And you have to be looking at the y values, and the y values need to have opposite signs, so make sure you know that. Okay, the next part of the assignment is checking basically if there are 3 solutions, so where does it cross over the x-axis? They're basically asking, all you do is you set x minus 2 equal to 0, x equals 2. They're wondering if 2 is the one of the three solutions. So all you're gonna do is in place of all your x's, you're gonna put a 2. 8 plus 4 minus 22 plus 10 equals 0. And since you got a 0, that means we found one solution of the three solutions. That's part 3. It's called the factor theorem. Okay, the next part, you're supposed to find a polynomial with a leading coefficient of 1 of degree 3, so it needs to be degree 3, and these are the three solutions. So if the zeros are x minus 3, because when you set it equal to 0, you get 3, x plus 2, and x minus 2. If you set all those equal to 0, you would go back to the 3 and plus or minus 2. But they want you to multiply this all out. So I'm going to multiply these two together first, and you get x minus 3, and you get x squared minus 4 when you FOIL those two. And then my final answer is x to the third minus 3x to the second minus 4x plus 12. Later on in this chapter, you're going to be given this, and you'll have to find these three, but it's easier if they give you those three to find a polynomial. And synthetic division is the last part of today's assignment, leading into the next section. They want you to solve this problem using synthetic division. At the beginning of the notes, we solved it using long division. This is just another method that's very similar to long division. You're going to put a 3 there. You're going to put a negative 4 there. You're going to put a negative 1 and an 8. And where I got those numbers from was the coefficients in front of all your terms. What goes inside the half a box is if you solved x plus 4 and you set it equal to 0, x would equal a negative 4. You did this in Algebra 2 last year. There's a little dotted line. This stands for the remainder, if you remember this from last year. You start the process by bringing down your 3 for synthetic division. And then once you bring down the 3, you're going to take the 3 and multiply it by the number by a negative 4, and you get a negative 12. You add it up, you get negative 16. Negative 16 times a negative 4 is a positive 64. And you add it up, and you get 63. And this is getting kind of big. But then 63 times a negative 4 is equal to a negative 252, which equals 244. Okay, you started it off into a polynomial. You have to put this back in. So it's always 1 less than what you started with. So 3x to the second minus 16x plus 63 with the remainder of a negative 244. That's called synthetic division. Let's do one more of these, and that's it for the notes for 4.2. So you put a 1 inside the box, and it's going to go 1, negative 3, positive 2, negative 4, positive 4. You always start the process by bringing down your 1. 1 times 1 is 1. Add it up, makes negative 2. Negative 2 times 1 is negative 2. Add it up, you get 0. 0 times 1 is 0. Add it up, negative 4. Negative 4 times 1, negative 4. This problem, you have no remainder. They still want you to put it back into polynomial form. It's always 1 less than what you started with. X to the third minus 2x to the second. You don't have to put the 0x in, minus 4. And you are done.